All right, thank you, Pengchi. Hello, my name is Sahas. I'm going to be one of your coding instructors for today. I am the computer science lead for UCR UAS, and alongside with me is going to be Scott, the other instructor. Scott, would you like to introduce yourself?
Hi, thanks, Sahas. I'm Scott Vo. I'm the computer vision lead of UCR UAS. I'm a second year computer science student, and I'm going to be handling the slides and the code today.
All right, cool. So, as Pengchi mentioned earlier, today is going to be our last session for Python workshop. So we're so glad everyone could make it. And today's session, session 5, will be regarding the applications of Python using the Pandas library, and we'll be learning how we can use the Pandas library for parsing and understanding large data sets in Python. So let's get started. So the first set of information that we want to kind of cover is the Pandas library and getting Pandas library on our particular devices. So in on session 0, week 1 of our Python workshop, we covered all of the different installations for all of the different workshops that we had going. And one of the particular libraries that we needed to install was the Pandas library. And the Pandas library is going to be essentially our data science library that we're going to be using in Python. So in order to make sure that we have not only Pandas installed, but also the latest version of Pandas installed, we're going to be going into the terminal in our VS Code that we set up on week 0. And we're going to be using pip install dash dash upgrade, which will be the keyword that will allow us to convert our current version of pandas to the latest version of pandas if there has been any updates recently. And after dash dash upgrade, we'll follow that with pandas because going to be up we're going to be installing the latest version of pandas. And then after we get all of that set up, just to make sure that we're all running the latest version of pandas, we're going to also run 2 lines of code on a blank.py file, which is going to be the first line will be importing pandas as PD, so that we don't, and the reason we do as PD is instead of having to type pandas over and over again during our coding section, we can just type PD to refer to the library. And then we're also going to print PD dot underscore underscore version underscore underscore. The underscores around version just notifies that we're going to be using particular, like we want to get particular information from this current version of our pandas library. So let's go ahead and do that. So we're going to go over into VS Code, and in the terminal, we're first going to start off by running pip install dash dash upgrade pandas. And then we're going to go ahead and hit enter. And right now, since Scott already has the latest version of pandas, it didn't take any time whatsoever to get that installed. But if you guys have an older version, you might see some loading bars go off, and it may take a few seconds. So I'll just give us a bit of a pause. And once again, yeah, the code that we need to type into terminal is pip install dash dash upgrade pandas. So once you have that done, we're going to now test and check if we have the latest version of pandas working by first running import pandas as PD. And then on the next line, we're going to print the version of pandas that we have by doing print, and then in parentheses PD dot that underscore underscore version underscore underscore. Make sure you have 2 underscores on either side of version. And then once we hit run, we'll print out the current version of pandas. So we're currently running 1.2.2. I believe so when you guys first installed pandas back in session 0, that version of pandas most likely was 1-0-5. So there has been a, a kind of an upgrade. So once you, any questions so far in terms of installation and getting all of this version stuff to install? All right. Well, In that case, we'll go back to the slides and we're going to kind of discuss a bit more about what Pandas library is and how we can use it. So the main component of our Pandas library are data frames. Data frames are essentially just two-dimensional arrays which will store all of the different information and data that we're going to be using. So in previous lessons, we covered one-dimensional arrays in the form of the data structure known as lists. Lists are one-dimensional arrays because you can only put items in kind of one singular row. Unlike, but in our data frames, for example, we're going to be actually using a two-dimensional array, which is going to allow us to not only fill in one singular row, but multiple rows. And so we'll essentially have rows and columns that both combine to form a two-dimensional array, as you can see in the image on the top right. And in Python, or in Pandas, a data frame is consisted of multiple one-dimensional arrays called series. So in the example on the top right, we have a few things that refer to how a data frame is structured. All the white space on the data frame refers to data. The orange the orange row is going to refer to tags, which will tag all of the different column names, and then the blue series or blue dimensional array, one-dimensional array, is going to be storing index tags, which will allow us to refer to each row in our data line. So that's kind of the general structure of data frames. So how do we create data frames? So before we create a data frame, we first need to store all of our given data inside of a data structure, and we can do this in various different ways. The one major way we do that is first we'd store all of our data in in multiple different one of different many different data structures. So we could use data structures that we've learned before, like lists and dictionaries, to store our data, or we can also use we can build series and put them together, or we can use nd arrays from NumPy, which is one of the libraries that Pandas actually uses, and we can also use existing data frames and put them together. And once we have the data structure with all of our data in it, the next part would be building our data frame. So in Python, how we would do that is we would need to construct a data frame using a constructor function. So that constructor function will be using the following syntax. So we first do PD because we imported our pandas library as PD, and so we do PD dot data frame, capital D, capital F. Data frame will be a function that acts kind of like a constructor. And what a constructor does is it'll take in different inputs in its inside the parentheses, and it'll build a data frame object based off of those parameters. So the parameters that we're looking at are data, index, column, dtype, and copy. Data is pretty self-explanatory. It'll take in variables that contain all of our data that have been convert that into our data frame. So that'll be our existing list, dictionary, series, ND array, and other kinds of data structures. The next one will be indexes, which are used for labeling our rows from the resulting data frame that we create. And it'll also take in columns, which will be used to label the columns of our resulting data frame. And dtype will be referring to what will set the data type for our data frame. So if we want to create a data frame of all floats, we set dtype to floats. Or if we wanted to create a data frame of all booleans, we would set dtype to boolean. And the last one, we're not going to be worrying too much about it, but it's going to be copy, which will just make a copy of an existing data frame if true. And an alternate way that we would go about creating a data frame in Python is, instead of having to go through the tedious process of creating lists or dictionaries with all of our data inside of it, we could instead write all of the data in a Excel sheet and convert that into a .csv file. And then using that .csv file, we could later convert that into a data frame using different kinds of procedures, which we'll cover in the next slide. So first, what we're gonna do in order, so prior to being able to learn how to index our pandas data frame, we're actually gonna go ahead and create a data frame. So we're gonna actually cover the two different ways that we create data frames from the previous slide. So let's quickly hop over to VS Code. And the first way that we learn how to create the data frames are by creating an existing data structure. So let's go ahead and create an existing data structure for a list data structure. And I guess we can put in shopping cart items in this one. So we'll just put milk, cookies, strawberries, and bread, I guess, I suppose. So we have our data structure, which is a list. And in order to convert that into a data frame, we would first create a variable that'll store our data frame. So we'll call it df for data frame. And we're going to create a data frame object by doing pd.dataframe. And we're going to pass in our array or our list. And then now if we print out df, it'll convert our list into a data frame structure. So when we run this program, we'll now see that it kind of converted it into a more complex look, because now we have a column 0, and then we have four different rows: row 0, row 1, row 2, row 3, all storing the different items from our list. So that was the first way that we can create our data frame. Now we're going to quickly hop over to the slides and take a look at how we can use a new function called read underscore CSV to convert a CSV file into a data frame. So um, in order to do that, we'll first need to use the read underscore CSV file. And we're going to use that on a CSV file that we actually got from the homework from the GitHub. So if any of you guys have been working on the homework, or not homework, I guess practice problems from our GitHub, one of the files included from that was a cars.csv file. And what we're going to do with that is we're going to convert that into a data frame using the pandas library. So instead of so in this example, we have import pandas as PD, then df equals pd dot read underscore csv, and the first line that the read underscore csv will take is it'll take in a file name, and right now the file name is just cars.csv because we're assuming that the program that we're creating in Python is in the same level in our directory, in our files directory, as where cars.csv is located, and then comma index underscore call equals 0. That is a flag or a parameter that will allow us to make sure that instead of having to use, so whenever we create a data frame using the read underscore CSV, it'll automatically create its own set of labels for the rows and columns. So what instead of having to use the instead of using the existing ones that come from using the pandas library, we can actually set index column to equal 0, so that we wouldn't have to worry about creating a brand new set of labels. Instead, we'll use the ones that are given from cars.csv. So let's quickly hop on over back to VS Code, and we'll go ahead and import that. So first, let's go ahead and locate where cars.csv is in our directory. So it's right. So we want to make sure we create our .py file in the same level as where cars.csv is located, as to make sure that Python doesn't have a hard time locating where this particular file is. So right now we have cars.csv right there, and then our demo.py program is within the same direct level of the directory. So in order to do our import, also right, you can also open CSV files in VS Code itself, and you'll just see all of the values separated by commas, hence the name. And now we're going to convert that into our data frame. So let's head back into demos.py. And we're first, the ideal way to set this up is we're going to create a variable called file name, and it's going to store a string which will tell us the name of our file, which is cars.csv. And then we're going to convert that into our data frame by doing pd.read underscore csv, and then in parentheses we're going to put our file name and index underscore call equals 0. So now when we print this data frame, we can now see that we converted our CSV file into a data frame, and it'll print out all of the information from that CSV file into and convert it into our data frame, so we can now manipulate that information within Python. And you can also notice that index underscore column equals 0. That allowed us to keep our existing column tags. So now we can use that. So if we, for example, forgot to include that, so let's remove the index call, and it will give us its own existing uh, labels, which is from 0 to 6, pretty basic stuff. And that kind of messes up our order because now we'll have an unnamed tag, for, unnamed 0, and which will store all of our country codes. So that kind of messes up our entire data frame. So we always want to include index underscore call if we have all the labels already preset. All right. So now that's how we can convert a CSV file into a data frame. Let's go ahead and head back into our slides and take a look at how we can index our pandas data frame. So pandas indices are similar to how dictionaries work in base Python, where you can kind of say I want to get information from this particular column or this particular row, and it'll give us that information. So if we so as we saw earlier, in order to print out the entirety of our data frame, we would want to just do print df, and that'll print out the entire data frame. If we want to just say print out a single column, like if let's say I just want to see cars per cap from my data frame, you'd want to use the command df and double square brackets, because the double square brackets indicates that we are referring to a column as opposed to a row. So in the double square brackets, we're going to put the string, which should be the label of the column that we want to print out. So in this example, we want to print, if we wanted to just print out everything from cars per cap, we just put that as a string inside of double square brackets. And this can also be extended to multiple columns. So if I want to print out cars per cap and country, all part of the same print line, you can just use the double square brackets and separate the labels by a comma. And the last thing that we're going to cover for this particular slide is how we can get the shape of a data frame. So if we want to know the exact dimensions that our data frame was built from, we can do df.shape. What dot shape does is so when we create our data frame, it will also store all of the rows and columns that were created from that particular data frame inside of our shape variable. So in order to access that information, we would just do df.shape. So let's go ahead and see what that looks like in code. So in our code, we're going to first go ahead and print out a single row, and a single column. And in this case, let's try to print out just drives right. So we're going to put inside of double square brackets drives underscore right, and make sure you're also storing this as a string. And then when we go ahead and run this, instead of seeing all of our data, we're only going to get the data for the column drives underscore right, and and it'll kind of exclude everything else. Now, if I want to include country as part of this list, and you can go ahead and do drives underscore right, comma, and then country. And in this case, when we run this, it's going to print out drives right first and country next, because we actually essentially switch the order based on how we ordered it in our print line on line 9.
So now with the next
Oh,
question.
uh, so the order got kind of swapped in this case, because on line 9 we first referred to the column drive underscore right, and then we referred to the column country. So if we were to just print out df on line 8 by itself, we would see that the order got swapped, because when you run df all by itself, it'll just print it how it got the data. But if you want to ever switch the data around, you can kind of use this, like switch the order of the data around. You can go ahead and use that mechanic in order to do that. And the last function that we want to cover is the dot shape function. So if we want to get the shape of or the dot shape variable, if we want to get the shape of our data frame, we can do df dot shape, and then this will print out the amount of rows and the amount of columns that can be found in our function. So it'll first print out the number of rows, comma, the number of columns, which is 7 comma 3. Any questions so far about how we can index particular columns in our data frame? All right, let's move on to how we can print out particular rows in our data frame. So another indexing mechanic that we're going to be looking at is how we can print out certain rows or observations of a given column. And we can actually mix and match columns and rows, it's like indexing different columns and rows to print out a particular row of our data frame and only get a particular column from that same data frame. So right now we're going to take a look at how we can print out certain rows, which is by doing print df, and just like how we can go through a regular list and like find only certain look at certain items in our list, we can use square brackets and then 0:4. So we would start at index position 0 or row position 0 and go all the way down to row position 3 because it's excluding row 4 or row index 4. So when we go ahead and print this, it'll give us all of the stats for US, Australia, Japan, and India, because those are the first 4 rows that we're going to be printing out. And notice how, since we didn't specify for any particular column, we got all of the columns to print alongside with those particular rows. Now, if we wanted to print out those set of rows and only take a look at cars per cap or drives right, we can also include that. So the formatting for that would be df single square brackets, because rows are actually going to be using only single square brackets while columns are double square brackets. So we'll do single square brackets 0 to 4, and then followed by, so you want to make sure this isn't actually included within the same set of square brackets, followed by double square brackets, and then the columns that you want to take a look at. And in this case, it'll print out United States, Australia, Japan, and India's car per cap and drives right, because we only took a look at those columns. And we can quickly see what that looks like in code as well. So let's say I only wanted to print out one item. The weird part about using this particular form of indexing for rows is if you want to print out just one item, you would think intuitively you can put in a single number, like for whichever row you want. But unfortunately, using this technique for data frames doesn't work. You want to give it a range. It only takes in a range. So for the single item, if I want just to print out the first row, you'd want to do 0 to 1, excluding 1, and this will print out a single item in our data frame. So let's go ahead and try running that. And yeah, that'll print out everything for the row US. But let's say I wanted to, if we forgot the colon and 1, and we just did df0, you would think that we would be able to access US's all of the stuff from US's row, but we would actually get an error because it requires an entire range. But there is a way around that that we'll take a look at later. And so let's go ahead and just print out a row 0 again, so 0 to 1, and we're going to follow that by double square brackets, and let's take a look at cars per cap. And now when we run this, we'll get a single set of information because we are only looking at row 1 and column 1. So this will give us United States' cars per cap. So this is one way that we can kind of narrow down our search in data frame. Now we're going to, on the next slide, we're going to cover how a different and much easier technique that we could use to accomplish the same results. So we can use keywords lock and ilock, which can help us a bit more easier with doing data selection. So lock can allow us to search rows by their labels, and you can also print out multiple labels by separating them by commas. So let's say I wanted to take a look at the rows US and Russia. We want to make sure that we do df.lock, which is the keyword that we're taking a look at, and then square brackets, double square brackets in this case, And inside of the double square brackets, we will put the keywords that we're looking at, which is US and Russia. And those will be the labels that we're taking a look at. And then if we want to do search by index, we would do iloc, and it kind of works the same way where you can do df.iloc square brackets and give it a range, but where it differs from the other technique is you can also print out single items from our data frame by doing df.iloc double square brackets 1, which will print out whatever is being stored in position 1 in our data frame, the row position 1 in our data frame. So let's quickly go see what that looks like. So the first thing we're going to do is we're going to print out using lock the position. Let's take a look at what's being stored in row for India. So we'll put IN, and when we print this, it'll print out all of the information in India. But the formatting, if we use single square brackets, is weird. So we actually want to use double square brackets in this case, and this will format it properly. Now, if we want to print using iloc, we'll go ahead and first change that to iloc, the keyword to iloc, and we're going to, let's say, print a range from two to from index position 4 all the way to the end. So we can do that from 4 colon and then leave the right side of the colon blank, and this will print from index position 4 all the way down. And that's using iloc. And then we can also further enhance using iloc if you just want a single row instead of having to do the weird like ranging thing from using the regular technique. We can just use double square brackets and then mention the index position of which row we want. And that'll just give us one particular piece. So that's how we use lock and iloc. Any questions regarding indexing? All right. If there's no questions on that, we're going to move on to how we can add into our data frame. So now that we know how to look at particular pieces in our data frame, if we want to extend our data frame to give it more functionality or give it more data, we can do that as well. And there's two major ways that we can do this and add new series into our data frame. The first one is we can pass in a new series into our data frame just as is. And the code for that would be first we refer to our data frame object df, and then we put square brackets, and inside the square brackets we'll put the name of our new column. So you can kind of see the structure of how that will be put together in our image to the right. So the top section is covering how we're going to create a new column series, and then we're going to set that equal to the new set of data. So we're passing in this case a list of items 1, 2, and 3, and that's going to be stored in our new column that we're adding into our data frame. The second way that we can put together or that we can create new like data in our data frame is by adding or actually applying any arithmetic equation onto an existing column in our data frame. So let's say I wanted to add the items in the data in column 1 and all of the items in column 2 together to create a new column 3. We can do that by doing df square brackets, and in the square brackets uh, the name for the label we want to give our new column, and we'll set that equal to df square brackets and then the label for one of the columns in our data frame plus df square brackets and the name of another set in our data frame column in our data frame. And it doesn't always have to be add. We can multiply, we can divide, we can do a lot of different arithmetic things to it. Think of it kind of like in Excel, where you might have two different cells and you want to kind of do an arithmetic operation on them and create a third cell based off of that result. That's kind of the same technique that's going on over here. So let's quickly take a look at what that looks like in code. So what we're going to do is we're going to quickly create a new column for average car weight, and this is going to be stored as kind of a list. So we're going to create new underscore data equals, and we're just going to put 7 different numbers really quickly because and this is going to kind of simulate how we're adding average weights into our existing cars. Let's see, it's cars Panda data frame that we created. We're going to put 7 different pieces of data, and then we can extend that into our existing data frame by doing df square brackets. And in the square brackets, we're going to go ahead and put average car weight, and then set that equal to new underscore data. So then now when we print out our new data frame, we will see that it appended that new set of information onto our data frame. And let's say we wanted to create a new column based off of cars per capita and cars per weight. We can actually multiply those together by doing average weight per cap equals df square brackets car underscore, or we can go with average car weight first, multiplied by the column for cars per capita. And this will multiply the two sets of data together and create a new column based off of that, just like so. So any questions on how we are able to extend data from an existing data frame? All right, if not, we'll move on to the next manipulation of data frames, which is removing columns and rows from our data frame. And just like with adding data frames, there are two major ways that we can remove columns from our data frame. The first way is by using the del function, where you would want to just specify the column you want to remove. So you do that by doing del df and then inside of the square brackets, the column that we want to remove. And the second way is by doing df.pop, and inside the parentheses, because .pop is a function, we're going to just specify uh, the label for the column we want to go ahead and remove. And then if we want to remove rows from our data frame, we use the drop function. And this is a little bit weird to work with because it doesn't permanently remove rows. What it does instead is it does, in order to use this function, we'll have to do df.drop, and then inside of inside of regular parentheses, we'll use the keyword index, which is the parameter that will tell us which index row we want to drop or remove, and we'll set that equal to the label for that particular row. Right now, we're not going to so we're not going to really show this code off really quick because we're kind of running low on time. So we're gonna skip this, but you can kind of copy and use this set of code on the slide to kind of test for how removing items work in using pandas. So let's move on to our next slide, which is sorting values. So in order to sort values, so once you have a data frame with data that you're happy with, you typically want to have it in a sorted value so that it becomes easier to see what that data looks like. So the way we do that is we use the dot sort underscore values function, and the parameters for this particular function is we need the by parameter, which tells us how we want to sort the data by. So in this example, if I want to sort the data by cars per cap, you set the by a parameter to, in square brackets, the label for that particular column. And then following that is another parameter for ascending or descending. If you don't have this parameter, it'll default it to an ascending order, but you can also set ascending equals false in order to set it to a descending value. And this doesn't change our data frame, similar to how dot drop does not. In order to get it to actually set it to that particular order, we want to use a third parameter, which is in place. And if you set in place to true, when we reset this to ascending order, it'll keep it that way so that you can use that new ascending order for, or descending order for newer uh, data calculations once you need that. So all of the code for that is shown right here, and we're going to move on to the last piece of information, which is data analysis. So data analysis is a really important piece of using data frames because um, Pandas provides us with a lot of different ways to extract different types of information regarding the data frame that we created. So the two ways that we're going to focus on are how the mean function works and how the standard deviation or STD function works. So the mean function will go ahead and find all possible columns that have data that you can calculate a mean for, and it'll calculate all that for you and print it just as you see on the slides. And right now, you would expect that we would only be able to get the mean for cars per cap because that's the only one that actually has numbers. But actually, drives right also gives us a mean. Does anyone know why we're getting a mean value for drives underscore right, even though we're only storing trues or false? Anyone in the chat? Right, it's correct. So true is actually the same thing as storing int 1, and false is the same thing as storing int 0. So what it'll do is it'll take true as 1, false as 0, add everything up, divided by 7, and that's going to be our mean. And we can kind of use that as like a percentage of how many countries drive on the right side of the road. And similar to mean, we std does the same thing except finds standard deviation for all columns that pertain to that kind of data set. And the reason why for mean we have to put axis equals 0 is because we want to be able to get all the information for all the rows. If you don't include that, I believe it won't do that. And if you do want to, for example, just get information for cars per capita, you can actually break a data frame into individual columns by using the square brackets. You can do df square bracket, double square brackets, and the name of our column that we want to find the mean for, and apply the mean function on that particular column. Um, any questions regarding data analysis? If not, there's one more kind of thing I want to mention. This is just two of many different kinds of functions that the Pandas library allows us to use. So, like you can always quickly check on Google or other kinds of sources to see the entire collection of different data analysis tools that are provided from the Pandas library, and many of them are pretty self-explanatory in order to use. But other than that, that is the entire lesson in terms of our pandas library. So, um, yeah.
Okay, Professor Rich, are you here?
Yep.
Awesome, awesome. We're gonna hand it off to you now. So feel free to share screen whenever you're ready.
Okay, sounds good. Let me go ahead and introduce myself for those who don't know me. My name is Professor Rich. I teach information systems over in the business school. And in our intro class 101, we are covering basic Python. We also have a 175 class, which goes deeper into Python. I'm going to share a few things tonight on how Python is used in business and also out in industry. First thing I'll share is this right here. So common functions in Excel being done in Python. You'll recognize the code, but it looks a little bit different than the IDE that you're using. I use two. One is Jupyter Notebook, typically for teaching, and then the other one is PyCharm, typically for presentations. We can see here that we have the same code that you've been working with all throughout the workshop: import pandas, import numpy or numpy, depending on how you want to pronounce it. And the code itself is not important. I know it's pretty hard to see on your screen, but you can just see here that we can create things like spreadsheets using Python and also the pandas package. Also down here, we can filter the data. So anything that you can do in Excel, or pretty much anything you can do in Excel, you can also do in Python. There are also some advanced functions here with Python. So if we go down to the bonus tasks here, so let's say that you want to get a list of unique items in a long list within Excel. This might be hard to do in Excel, but here we can just throw everything into an array and then find the unique items there, and it spits it out into a separate array. So this is the kind of introduction to Python here in business. Next thing I'll share is the same Jupyter Notebook environment. However, this is building an amortization model. So if you're interested in finance, this is something that you might be working with using Python. So here we import a lot more things into our environment. And we define a function here where we take in principal, interest rate, years, payment, everything. So if you are not familiar with finance, this doesn't make sense to you. If you are familiar with finance, you will recognize some of these terms. And this function creates a model, which then spits out statistics here. So payoff date, number of payments, interest rate, and so on. We can also spreadsheet that like this. And also we can use the data visualization packages to plot these. So now we can show a payoff timeline, interest payments, and things like that. So again, this is all things that you can do in Excel, but there is a limitation in Excel in that when Excel was created, it was not meant for huge data sets. So if you tried to do this with a spreadsheet of, let's say, 1 million rows or 10 million rows, your computer would crash. Whereas Python is better designed to handle larger data sets. So let's go ahead and jump into just a very short lecture on the uses of Python. In business, we know that we can use it for machine learning, as you have learned throughout this workshop. Machine learning is also useful for things like data analytics or predictive analytics. So what will our sales be next quarter? How does the pandemic affect our sales, affect our customers? Everything like that can be done in Python. You just saw an example of Excel, and I will share a document with everyone a little bit later. But a data scientist recommends that if you spend more than 4 hours of your day in Excel out in industry, it is worthwhile to learn Python and R. So again, Excel was not designed for large data sets, nor was it designed to be very quick. So Python, and also the combination with R, is a powerful tool when you go out into industry and you'll be spending a lot of time in Excel. How else is Python used in industry? Many of the major software companies use Python, and you'll find that, you know, if you really want to get into Python, CS is a good major. If you just want to use kind of the business applications of Python, then that would be more found in the School of Business. Something that might surprise you is Python is also used in gaming. So if you've ever played The Sims, you can mod The Sims using Python code. So this is a good way both to mod the game to how you want it and also to practice with Python. Last thing I want to leave you with before we move on to that document is, why do we learn programming? So many students in my class ask me this. They are non-technical, they want to major in finance or marketing or management, and they think that they will never use programming ever. And my answer is always, it's about the logic and not about the code. So as we move deeper into artificial intelligence, automation, things like that, if you want to stay ahead of the industry, if you want to get a job, if you want to keep a job, it's important to learn the logic so that you are in control of programming or creating this automation and not someone who is being automated away. So again, it is about the logic and not about the code. I'm going to paste in a link here to the chat, and this link will also get sent to the UAS team so they can put it into their documents. But here is a document that I created with all the resources that I mentioned here today. I'll go ahead and share the screen, even though I see many of you looking at this. So this first link right here goes to my email. Feel free to reach out anytime with any questions. Right here, uses of Python. First, to scale or enhance Excel. There's that 4 hours quote, and you can read more about that data scientist right there and why they think it is important to learn Python if you're going to be working deeply in Excel. For Python in industry, there's a blog article talking about 8 software companies that use Python. And there are other companies that you might not imagine using Python. For example, Industrial Light and Magic, ILM, the special effects studio that works on Star Wars movies and other, Pixar and Disney movies. They use Python. Also, Python in gaming, right? You can mod your Sims game. And again, if you know the logic behind making computers do things, you can mod maybe any other game, you can design games, and you can also keep yourself relevant in industry. Python is a very teachable and learnable language. For example, if you are familiar with Java and you want to print something to the screen, you know that the syntax is system.out.print and then whatever it is you want to print. If you want to print something with a new line, it's system.out.println and then whatever else you want to print. In Python, it's just print, right? Open paren, open quote, close paren. So a lot of people are using Python to learn about the programming logic. Another thing I tell my students is if you know Python, you know JavaScript. If you know Python, you know C#, you know Java, you know Node. Sure, some of these syntax will change, so it's not a direct one-to-one map, but all of these languages, they have things like variables and lists and for loops and while loops. So once you understand that logic, you can then take this logic into any other programming language. I have an example here of robotic process automation. And this is a rapidly growing field of automation that many businesses are starting to pick up. Here's an example. Let's say that you are a new employee at a company. And when you start on your first day or before your first day, you have to fill out some forms. And let's say that you type all this information into a PDF. There is someone at the company who then takes your PDF, copies that information into their system, and then uses that information to generate like your security badge or your ID or your like net ID or your login or something like that. What companies in this position are doing is using robotic process automation or RPA to automate this. So can a human look at the first name text box and the last name text box and then copy this into the computer system? Yes. If a human can do it, a robot can do it. So program a robot to look through the PDF that you filled out, find the first name text box and the last name text box, and then copy that automatically. So this is a nice bridge. Ideally, you would have the user input this information directly into your system or via some sort of web interface. But if not, then you can use RPA to automate these things. And for anyone who's in my 101 or who had taken my 101, I always joke about like accounting, how it's going to get automated. I have an accountant. And I send him all my things and he sends me back a form, I sign it, and then he sends it off to the IRS. The value of being an accountant is not looking at my documents, finding the right number, finding my salary, finding my whatever, and then putting it into another document. The value of an accountant is saying, hey, maybe you just started a new job. What are some money saving tips you can do? Maybe you move to a new state. What are some tax rules that you need to know about? Things like that. So if a human can look at a number on one form and copy it over to another form, it can be automated by a robot. And those of you here today in this workshop, those of you reviewing this workshop via video, you want to stay ahead of the industry and understand how automation works so that you can be the one automating the processes instead of being automated away. Down here, I list a lot of resources that you can use to go deeper into Python. One of the hallmarks of all of my classes is I don't believe in making students pay for things. So I always use free textbooks and free resources. Here are 4 very good ones. Python for Everybody. If you are familiar with Dr. Chuck, this is the book that he wrote. The other 3 are really good as well. I would suggest taking a summer or maybe a month and work through Automate the Boring Stuff with Python. That has a lot of examples of how you can automate daily tasks using Python. So if you need to batch rename, a bunch of pictures in a folder, you can do that with Python. If you want to combine Excel sheets, you can do that with Python. If you are able to make it all the way through 4 of these books, then you are pretty set for working with Python to the point where you could probably apply for like an internship and get in just based on this knowledge alone. If you want additional resources on the business side, there is a blog called Practical Business Python, and they post articles about, here's a business case and here's how to solve it with Python. They have like financial models there, things like that. So just something you could read in the future. And then if you really want to go deep into Python, I've included some low-cost courses here. So there are 2 courses on Udemy that I personally recommend, and I also use myself. So for Udemy, if you're a new user, look for sign-up deals where the prices drop to like $9.99 or $14.99, somewhere around there. And then if you're an existing user, wait for similar deals. So don't ever pay full price for a Udemy course. Just wait for a deal to come out and you can grab a good course at a really low price. I like Udemy and similar platforms because the content is always being updated. So for example, if you click on that Complete Python Bootcamp, it'll say 2021. And then you check it next year and it'll say 2022. So there's always updates being made. So you get really good value for your money. Another great resource is Codecademy. And this is not limited to Python. You can use Codecademy to learn almost any programming language or all the major ones. Their free Python course covers Python version 2. And this is an outdated version of Python, so that's why it's free. The newest version, the current version of Python is Python 3. And that course requires a pro membership, which does have a student discount. If you are thinking about a pro membership, it gives you access to everything that's pro in Codecademy. So I recommend making a list and a schedule of courses that you want to take and you can finish within a certain time limit, let's say over a summer. That way you can only pay for, let's say, 3 months and then get the most value out of your pro membership. Same thing with the textbooks. If you can make it through one of these low-cost courses and you made it through all 4 textbooks, you'll be squared away with Python, and then you can check with the UAS team if they have any additional resources. If you want to specialize in, let's say, like machine learning or something like that, you can also email me and I can provide some resources as well to guide you there. So that's all I have for the business application portion of this workshop. So I'll turn it back over to Scott.
Yep. Hi. Thanks, Professor. Yeah. Thank you again for giving us all those resources. I think everyone's really appreciative of that, and we're definitely going to use that to get a little bit more ahead in Python. So yeah, that was our Python workshop sessions for this quarter. I hope you all enjoyed and learned some new things. Yeah, and before we end off, I think we didn't mention our keyword for the extra credit for those of you who have professors giving extra credit. So we do have the keyword today. I think is going to be panda, if that's correct. But yeah, so I'm just gonna hand it off to our technicians really quick to end off this meeting before we go into office hours.
Hey, hi everyone. My name's Trang, your in-house technician. You've seen me before. You've seen this slide before. But from the bottom of our hearts, thank you for sticking with us through this whole workshop series. Yeah, so as you know, we are Unmanned Aerial Systems. We build planes and we try to provide value to educate everyone, through these workshops. Yes, Professor?
So real quick, I just wanted to take a screenshot to commemorate this workshop to post on LinkedIn, and I'll tag the UAS e-board, and you can tag all the attendees as needed. So if you're okay with that, go ahead and turn on your camera. And if you're not okay with that, go ahead, leave your camera off. You know the drill. Cool.
Group photo.
Group photo, 1, 2, 3. One more. Cool. That's it on my end. Oscar, no webcam. That's okay.
Thank you.
Thanks,
Thank you,
Professor.
Professor. Okay, well, anyways, it's okay. So a few quick announcements from our organization. So next slide, please. Yeah, we have our general meeting this Friday at 7 p.m. If you guys would like to come hang out and learn more about our organization, then you're always welcome to come learn more about us. And we're also recruiting for anyone who's interested in working on electrical engineering, designing the electrical system of an unmanned aerial vehicle, then feel free to contact our EE lead, Jeremy, and find out more, apply on our website. So that is all from us. And thank you again for coming to our workshop. It's been a great pleasure helping you guys learn more about Python. We are thinking of hosting an Arduino workshop next quarter. So keep an eye out, subscribe to our newsletter, check out our website, and we'll keep you posted on everything that we have. Okay, that's it. Thank you, guys.
Thank you, everyone.
Thank you again for coming, everyone. It's been a pleasure.
Thank you everyone for coming today. We'll be sending out certificates next week for those of you who showed up frequently. Yeah.